Меня зовут Sebastian. Я работаю в качестве евангелиста программного обеспечения для IBM. And that's about all I can say. Я учу русский, but I think it's easier if I talk in English. So thank you very much for the introduction. And we're going to have a session today about progressive delivery and how to deliver our production applications, and especially in a cloud-native world. So you might have heard of cloud-native technology. You're probably already using them, right? Like Docker, Kubernetes, things like that. And we're going to have a look at where we can go with this. So I'm typically not that good at slides, so I only have a few slides for you and a lot of code. So that's a little bit about me, a lot of Java things involved. So typically I'm more like on the enterprise Java side of things. I'm a lot involved into projects, enterprise projects, but also on DevOps topics if you want, and continuous delivery, progressive delivery especially. So that's about me. And then for continuous delivery, I kind of understood the introduction, but again, who is doing proper continuous delivery in a way of that one commit already ends up all the way through the stages? Hands up. Who is doing proper continuous delivery? Okay.
Так, но если вдруг кто-то не понимает CI/CD, у кого есть?
Right. So, and who is deploying all the way to production when you commit some code that it will all the way end up on a production environment? Okay, that needs to be. So if I come back, like in the future, you have to raise more hands, right? So that needs to improve. All right, with continuous delivery, it's basically why should we do that? It's a question of how do we deliver our applications to production in a properly well-defined way, right? So it's reliable, it's fast, it's automated. And of course, we should not do this manually, right? So you write some code, you do a code change, you push it into your version control, and then you need one process that just delivers it without a downtime all the way to production, with proper tests, with the verification, so you're sure that it actually works, and things like that, right? So that's an interesting thing. So who of you uses cloud-native technologies such as Docker or Kubernetes in production? Oh, wow, that's good. Who uses Istio or service mesh technologies? Okay, a few. Okay, we're gonna have a look at that. So that is about Kubernetes. You're probably then you're very familiar with that. Important thing is production-grade container orchestration. I will talk about that a little bit more. The nice story why I'm a big fan of Kubernetes is that, well, it solves a lot of things for you out of the box that you would need to do manually otherwise, right? A lot of companies have built sophisticated environments that do things, very similar like this, but now we have, an open source, well-defined, de facto standard way of developing productions and production applications and how to deploy them in an environment, right? But admittedly, it's not easy to use. Who thinks Kubernetes is easy to use, especially for DevOps engineers? Or I'm usually more on the development side for developers who typically don't like the YAML format. Who likes the YAML file format? Yeah, a few. Oh, okay. Okay, I'm definitely on a DevOps conference. I need to be careful. Typically, that is zero. Nobody likes it. It's not necessarily easy to use. So the question here is, if we have something like a Kubernetes cluster, how can we, do the whole CI/CD technology thing, and especially continuous delivery, and then later on progressive delivery, in a somewhat sophisticated way? Because we could build up everything ourselves, right? But especially in the same way like Kubernetes came into play, we have a few technologies who are already emerging, and one that I want to show you a little bit more today. So everything that I want to bring to you, it's more like a general applicable principles, but this is one implementation, what you could use, one technology that is called Jenkins X. Jenkins X, who of you knows Jenkins? Okay, then you probably don't know Jenkins X because most of it, what it has in common is the name. And the developers originally, but Jenkins X is basically a CI/CD technology for the cloud, right? And especially cloud with, how I would write it, with K. That is on purpose. That's not a typo. Cloud as in Kubernetes. So Jenkins X is tightly coupled for Kubernetes. If you don't do Kubernetes, then don't do Jenkins X. So they're pretty much married. And it provides a lot of glue for components that you would need to build up yourself otherwise, right? So it's based on some opinionated workflow and some opinionated idea that comes out of the box, and you don't have to start from zero, right? Similar to Kubernetes, you can start right away, and it has a default workflow that should be sufficient for a lot of applications. It's based on GitOps. I'm pretty sure you're familiar with that idea. So we want to have an infrastructure as code way to store our artifacts, especially the environment configuration for staging, a test environment for production. And if we want to make some changes on these environments, then we basically make code changes, push them into a Git repository, and then some process will roll them out for us. And this is, I believe, a very sophisticated way and what we should do in order to be, resilient and in order to be reproducible. So we always know what we're deploying to these environments. Jenkins X is further based on Helm charts. So if you know Kubernetes, probably familiar with Helm, that is one way to package applications in, basically something like a zip file or tar archive. So you put all these nice YAML files, including some templates if you want, into a chart, and then you can roll out these charts, again, in reliable ways with versions attached to them, and you can say, okay, now please roll out that chart. That then rolls out your application in, including everything that the application needs. So with proper versions, with these Kubernetes services, deployments, and other things like that. So I have some more fancy ASCII art diagram for you. So this is roughly how our Jenkins X structure would look like. The point is, unlike most CI/CD servers, here we don't have a centralized component. So it's basically similar to an event-driven architecture. It's built upon multiple components that communicate to each other via events, right? So the first thing what happens, you commit, or the developer commits some code into the repository, and then some webhook, what is internally served by Knative events, the newer version of Jenkins X, then triggers just some execution. Jenkins X is further based on Tecton pipelines. Might have heard of that, right? New cloud-native way of basically executing tasks or executing pipelines, such as in CI/CD, and then they will run. So again, based on GitOps and the idea of that you just push something to a Git repository and then merge via pull requests. So you build and create a pull request with the first build that you do. So you build your application, then you will have something like that's a Docker repository and a Helm repository, Helm chart repository is the name. And then, of course, as you can imagine, we will create a Docker image, right? And then we create a Helm chart that we store there. And then what happens is that all of these changes to our environments, here we have Kubernetes namespaces. So what we do, we separate our environments with, Kubernetes namespaces, such as JX staging, JX production per default. Of course, we could also have different clusters, right? Depends which approach you want to have. Maybe you have a separate cluster for a project, company-wide cluster for multiple projects, right? And then what you do, you apply these Helm charts, right? Because basically how you want to do the deployment is in a reliable way with specific versions attached to them, right? You just tell them, please now apply the Helm chart with the following version. Please now deploy my application in the following version to staging or to production, right? And then you build up that flow. JX promote is then was basically a command to promote, which means put the staging state that we have to a production environment, so basically promote that, right? If you have any questions to that, later on we will have time for questions. Basically how that works, I now want to show you a little bit of code. What I do is mostly related to Java, so I have a Java project that is built via Maven, but again, it's not that much about the technology here. This is most of it how you configure the Jenkins. That's pretty much the whole pipeline, because it's built on so-called build packs. So that build pack comes out of the box. Of course, you can then clone and provide your own implementation of that. what your project needs, but that is some sophisticated thing that already comes out of the box. And then just basically a few examples. So this is my basically my code in Java. It's like HTTP hello world, right? And lublю coffee. So it says coffee hello world, and then basically what I can say, I can go to my staging environment, and I hope the network will work out that way, that it then says hello or coffee in that way. Oh god, yeah, coffee. And this is now the application that is deployed to staging. And then how we operate our Jenkins environment here is with the command JX. That is a command line command. So again, Jenkins doesn't have a centralized component, not a centralized component that you communicate with. Most of Jenkins X is basically this JX command and a command line, and then it communicates with components that are deployed, which are deployed to Kubernetes, right? Similar what your kube control command would do, right? It's also very much isolated from each other. So you can say JX get applications, and then you see the applications that are currently deployed. And I have my zero downtime coffee shop example that is deployed in a specific version to staging, and this should be a table, and to production, right, in that specific version. Okay. And then I could have a look at the pipeline, whatever's running there. But basically what I want to do is I want to make some code change and then see what happens, right? So let's change this coffee to no more. Okay, coffee. Yeah, it's harder than you would think if you never typed on such a keyword, right? So yeah. Thank you. So let's update that. So what I'm doing, I'm pushing this to my Git repository, and then what happens? Well, that trigger will trigger the execution of of a pipeline, and then what I can have is get activity. I can have a look at the activities in my Jenkins, what's going on. So these are old ones. And then at some point, I want the activity to be triggered. So this basically listens to whatever pipeline is being executed or would be executed. And again, I don't specifically talk to a server or trigger anything. I just wait for, the Git repository. In this case, I'm using GitHub webhooks to trigger that pipeline. And it will take a second until that happens, and then it will basically start a new execution of that pipeline and then run through. And then there are a few promotions involved. So as you can see, it will then immediately go and create that promotion on that staging environment. And then later on, we can promote that to production environment. So this is basically the idea of that. And for us, I speak mostly for developers, that is easier to operate then. And for the whole DevOps engineering team, this is how I see this topic, then it's easier, to set up. Because that whole configuration that you just saw was basically it with the installation that we would do on such a JX environment to install our application, to basically set up all the different pipelines. And then, let's see what happens here. And then it will be rolled out to a production environment. In the meantime, what I can show you is basically the environments from the GitOps perspective. Okay, the Wi-Fi will speed up a little bit. So we have two Git environments here for staging and one for production. And they include some code, and then of course, we will create some new commits and change requests here. So basically, what happens if you have seen such a Helm chart, it will tell us, we have a bunch of applications, bunch of Helm dependencies that we provide here. And then, it's a little bit too small. Then we basically say, please roll out, please include this Helm chart of our application. Where does it reside? Well, in our Kubernetes cluster. Actually, Helm and a few other dependencies, it resides within our whole JX environment, which is our Kubernetes cluster. So where does all of these JX pipelines be executed? Well, in our Kubernetes cluster as well, right? In a specific namespace. There is another namespace, JX, that then, oh God, this does not, I hope this will work soon. That then includes all of these components. Oh yeah. No, this was from before. We can have a look at the environments. So there is a, development environment. Where is it? A staging environment here and a production environment. And again, you saw the application before. Nope. JX get applications. And then we see the applications that are currently deployed. So I hope now my pipeline will soon start. I hope this is not a issue with the Wi-Fi here. Because basically once we commit something to a Git repository, that works on the cluster environment because the Kubernetes cluster does the whole eventing and handling of the events that have been pushed to Git, right? So I don't do anything here on the, unless it has been pushed, yeah. Let's try this again. Not that in case my push didn't go through, so that's the only thing that can go wrong. As soon that commit is being pushed, my pipeline will start running. Everything up to date. Well, let's see. And then at some point it will end up at my staging environment, and then we can have a look at the staging and then promote it further. And then the promotion part, that's the interesting thing, because then we will have a look at the progressive delivery. And while that happens, I will just continue with this one. So what the talk is being titled Progressive Delivery, or how to, well, be able to sleep better at night. So how can we roll out our applications in, well, first of all, what I always care about is a zero downtime approach. So with zero downtime, you're trying to, well, roll out your release, your application without a zero downtime, without any downtime of any request. In theory, this sounds simple, but in practice, well, you know that you really have to make sure that not a single request is being lost, right? So when you do the transition from one application to the other, first of all, you have to know what your load balancer is actually doing, how it handles the connections, and how your applications will start up and shut down. And the next thing we have to talk about, well, migration and database compatibility and things like that of external systems that you have access to. So that is one important thing, that we can roll out something without a downtime. But even then, the question is, okay, if I roll out something on that environment, and if I make that switch somehow from old version to new version, then it's always a somewhat big bang, right? So that's always immediately new version. And ultimately, you can test very, very well before in a staging environment or in other environments, and you should do this in an automated way, right? Like including proper automated end-to-end tests that you can fire against all of these environments that we saw. But even then, ultimately, the only test is production, right? Because only then you see whether it actually works and whether it actually delivers value to your users. And what progressive delivery is doing in an automated way is, well, having sophisticated metrics and processes of applying canary releases and trying to detect, okay, whether that release is valid, whether it works. So you have a canary approach of saying, how does a canary release work? Well, you don't do a big bang deployment. You just say, let's deploy to 5% of the user first, or to a specific, group of users or something like that, and then gradually increase that. So don't do that big bang. Do 5%, 10%, however you want to increase that, until you reach a certain number, and then you're sure that it works. And the point is now, of course, you want to automate that. So we don't do A/B testing here. So we don't trying to figure out, which version is better. We're not trying to have a look at humans to see, which one is better and then decide that. No, it should be done automated, in an automated approach. So what we're trying to do, we define a proper process of saying, do the rollout in a gradual way, and then have a look at specific metrics to see whether that rollout is valid. For example, have a look at the error rate, or the response time, or what the application is doing. And you can insert all kinds of probes or all kinds of metrics, like key metrics that tell you whether that new canary, that new version of your application is valid or not. And then you also should do the decision in an automated way. That means if you do these metrics, if you take these metrics, these measurements, and decide, okay, based on the error rate or something like that, it is not valid, well, then you should do a rollback automatically. And with that canary approach, that is quite easy. You just say, okay, now we had 50%, 50% or something like that. It was not valid, okay, then roll it back and take the old version and do the routing more to that version that is actually still there. So, of course, you then have two versions of the same application live in production if you want. So that is also an interesting thing to take into account. So how does it work? Oh, that doesn't work at all, as I can see. Let's see whether the application has been updated, but that's still, yeah, that is still this version. Okay, this is interesting. Could blame it on the Wi-Fi, but let's see whether the 0 downtime. If not, then we would have to do that in theory, but seeing something that actually changes is, oh God, is better. So now in the same way, like we had this Kubernetes technology, what we can do with, yeah, this works. Okay, the commit went through. Let's see whether also we have some webhook here. We could live debug that. That's the fun part, I think, of having live demos. Everything can go wrong, so that's the exciting part. But also, that's sometimes a learning part, because guess what? This is what happens to you as well. And then we can, later on, and then we can have a look together how we could debug that as well. So that webhook that goes to my Kubernetes cluster, that seems to work still. So maybe we would wait a little bit. What also can be that this connection does not update depending on how the internet connection is. But anyway, I asked before about Istio. So what is Istio? And this is now a little bit helpful for the technology that we're using here. Istio is a service mesh technology that pretty much builds upon what Kubernetes is doing. So we have a mesh of interconnected service deployments where we can add some additional concerns if we want by the on the communication layer. So we, with Istio and the service meshes, we install so-called sidecar proxies along to our application, to the containers that are running, and they will proxy your connection, and they will, well, can make different decisions. And Istio specifically is very powerful with routing, with traffic management. So if we say our application A calls application B via HTTP or another, another technology, and now that service discovery and that connection should not be a part of the application. That is more like an architectural decision, but it should be part of, well, the communication layer, so of a specific, in this case, service mesh infrastructure layer that then can actually make some decisions such as service discovery or rerouting or load balancing, things like that, right? So if you have multiple instances of a service B, then it could, load balance, or it could decide now we actually do this canary release, and now we have different subset of versions, version old, version new, and then these proxies that do the routing internally inside the cluster, they can make the decision, okay, now go to the old one, go to the new one. And this is very powerful, and we can use that, again, in YAML resources, so with infrastructure as code. But then if we would make such a rollout, such a progressive delivery approach, we would also need to do it ourselves, right? So this is, I can show you some resources that are on the cluster. Kube control get virtual services. For this case, for all namespaces, so we can have a look at that service here, and what you can see, that's actually the good news of Istio. It uses CRD resources for Kubernetes, so it extends your Kubernetes resources for the Istio types. Virtual service is not a Kubernetes type, it's an Istio type, but you can use the kube control commands for that as well. And then we see some nice YAML. And from what the virtual service is doing, well, it's very basic. It says, well, if somebody wants to call this zero downtime Kubernetes, my coffee shop application, then please route it to one destination, which is actually the application, right? Or what you can see here, route it to two destinations with a weight attached to it, right? route 100% or 0%, 50-50 or whatever you want to do. And now you can already imagine, okay, we had a canary release before, so we have another destination that now is empty, but what you would do is you would set up a different destination here and then change this routing. So that is basically the handling, how you would tell Istio to route to one or the other. So again, if you would do this manually, then what you would do, you would take this resource definition in your code, right, in your repository, and then change this to 95 and this to 5, right, once it has been deployed. Okay, and then you see what's going on, you apply it, and then you see a request, you can have a look at measurements, and then you can increase it. But again, this would be a manual process. You could build this up, of course. A lot of companies have done that, but we want some, well, technology that already does it for us. So this is another one, again, one example. It's called Flagger, that does this for us. So it basically is a cloud-native technology that has solved this problem already. That says, okay, we have it based on Istio. We have this environment where we have these virtual services that route our definitions from one to the other, and now we want to make this approach that once we deploy a new version, it automatically takes this approach of, hey, wait a second, don't deploy it in a big bang deployment, but do the deployment gradually. And you can point it to so-called metrics. So that is then called get canaries. And we have that, it's called canary, I think, well, makes sense. And this basically says, well, for the following deployment, do the rollout here with, well, specific, here take the reference to the deployment, and then gradually do it in so and so many steps, and include some metrics. And if you know about Istio, you see that Istio already comes with some metrics. That is the monitoring part that is included in Istio. Who of you has tried Istio with Grafana and Prometheus? Oh, okay, only a few. So if you know about Istio, then it out of the box comes with things like that. Let me reload that. Oh, it doesn't include the namespace. Okay, what's wrong here? I'm not that happy with the Wi-Fi. So anyway, what this is Grafana, a monitoring technology. One of the many, you probably know many more than I know. But the nice story is this comes out of the box, so it ships with already quite a few things if you install Istio, and it comes with some out-of-the-box analysis for the whole traffic management. So it includes some out-of-the-box metrics for, you know, what is the success rate of my HTTP requests, what is the response time and things like that. And what you see here from, well, blue-green, it can even compare, well, the primary release to your canary release. In this case, I don't do a rollout right now, so they look equal. But then you would see, well, what is the success rate, and you would see the transition once we do that deployment from 5%, 10%, that it gradually one increases and the other one goes down, right? And these metrics are being used to make that decision whether or not we make a rollout. All right, so that is how we would apply this. And then if you've, let me show you another thing. If you have made some Helm chart, this looks a little bit crazy. If you built Helm charts before, that's basically how we built this canary Kubernetes resource, this YAML file. And then, well, we apply some templating here. So this is how typically a Helm chart is being written or is being developed then by the DevOps team to say, okay, do all of these rollouts here, but make it configurable by some values that you insert. So say, okay, take the following Istio gateway to the following host, and so on and so forth. And then once we apply it, this will gradually be rolled out for at least, or is it JX, for the production namespace. Okay, once that is the case, oh god, Xgate applications. Okay, I have to apologize for this. I don't know why this is not starting. What I can try, I manually start the pipeline. Maybe this will help. So typically that should be triggered by Git, but then in this case I say, okay, I have a pipeline. Again, it uses Tecton resources. I have this pipeline in my system, and then I can, if it even wants to start, okay, then I can start that manually, and then it will start that build and do the rollout. Okay, so that will hopefully start our pipeline and roll it out to a staging environment. And once we do that promotion that I showed you before, then we could see that promotion in this gradual way. All right, okay, maybe no. Let's see. Another thing that I want to talk about, this is a little bit more on the development side of things, but it also tackles the, well, operations part. Database migrations are basically any migrations that an application uses once, well, you want to do the zero downtime, right? There is this notation, a friend of mine said, behavior is easy, state is hard. So if I have a stateless hello world application, it's easy to, you know, go from hello world to goodbye world and change that. But typically, once we include something like a database that is being used by multiple instances or an external system that has a specific schema, and then we make some changes and refactor a database, refactoring these schemas, well, then it's a little bit more complicated. Why? Because if we do something like, oh, database, now please rename that table or rename that field even, that column, or change the type of the column, well, you can do it. But the point is, once you do a zero downtime release, I mean, not even canaries, but then definitely, but even that zero downtime approach will have both of your versions of your application, version old and version new, in production at the same time. Even if it's just for like half of a second while you do this switch, because otherwise it would not be zero downtime. You have to have some overlap, even if it's small. And that overlap causes you to have, well, you're forced to do something that is called n-1 compatibility. So your version n and your database schema version n has to be compatible with n plus or minus 1 with the next or the previous version. Otherwise, you know, you could not do this migration approach by overlapping the versions while they're running in production. And that is an important fact. It's a little bit sad, especially sad for us developers, because we have to deal with that. We cannot just throw it away and do it again in a different way and refactor easily. We have to basically say, well, we migrate in steps, not in jumps. This is because of the rolling upgrade approach that we do. And what that means, well, there are a lot of resources out there refactoring databases, I think is the name of a book, what you can have a look at that. I would just want to give you some small code example here. Again, it's not that much about the code, but just that you see this. Assuming we have some coffee order, and this is now a little bit of Java code, but this should not scare you. It's, well, basically a declarative mapping, how we map some order class, an object, into a database using JPA, and you could use Hibernate for that if you've heard of these technologies, by basically mapping a bunch of properties of a single order to a database table, something like we have a coffee order that has a coffee type, you know, such as espresso, cappuccino, and a bunch of other things. And once we would like to rename, let's say, this field type to coffee type, right? How do we do this? So assuming this is the initial SQL, how to create our tables, right? We have a type field here. And then basically what we need to do is to, well, create some more, where's my repo? DB step. Create some more resources, and specifically a sophisticated way how to roll them out. So first of all, and this is the part where the DevOps team or part needs to work together, we have to define a proper approach how to roll out and migrate changes before we deploy an application. So first of all, again, these versions need to be compatible. And then also, once we deploy a new version, or even when we do a rollback, deploy an old version, we need to make sure that before the application starts and accesses the database, these changes are being rolled out. And that is the next thing that we, well, should define in a standardized way. It's not quite standardized for cloud native applications yet, but basically what that means, we would need to have a bunch of in this case, SQL scripts or migration scripts or migration definitions that we roll out gradually, defined by versions. So then database schema version 2 would do something like this. Take the table orders and add a column that is called coffee type. So now again, we want to rename type to coffee type. And we cannot just remove or rename the column. Otherwise, it would fail. So we migrate in steps. We say, okay, now add a temporary column, and then change it, and then remove the old column while gradually change the code at the same time, right? So you might have seen that approach to say, okay, now please add the following type, the following column, coffee type, okay, and in the same way, please drop the constraint. So if you have a not null constraint, for example, you also, by gradually migrating that, you have to remove some constraint, at least temporarily. Otherwise you say, oh, if you now add a new column and it's not null already, then all of the existing data would, it would fail, it would not work, that transition, and things like that. So you have to gradually, subtly make that transition. And then in the code you do a similar thing. You add a temporary column, which looks very ugly. And then there's some automated extra persistence duplication mechanisms. Basically what you do, you first of all add a temporary field, then you write to both, and you read only from the old one. And then in the next step, again, migrate in steps, not in jumps. In the next step, what you do, well, you swap these two. So then this is the new one that you access to. You read from the new one while copying all the data, and then you have the data copy to the new one, and you only write to the new one. Then you can add some constraints, and then in the next step, well, what you would do, you can change it that then only the new database column would include that. Oops, step 4. That's what I wanted. And then you can remove the column, right? And in the same way, remove that code. And then you're basically done with that transition. In the same way, and then this a little bit depends on how you want to make that approach. You want to be sure that the rollbacks also work. Who has a continuous delivery pipeline that allows roll forwards and rollbacks? Oh, not bad. But rollbacks are typically, no, we never roll back, only way forward, right? Depends. So if then, say, we also include a script, well, to go from database schema version 4 to schema version 3, that will be this, add the type again, and then, now remove this not null constraint again, and then, in this case, remove this temporary table again, or column again. So you might have both directions. So this now looks like a lot of effort on the development side, and yes, it is, but it's basically the only way how to guarantee that if you do zero downtime migrations and, well, if you want to or if you have to fulfill this N-1 compatibility. So that is just the approach. That is one example how to add, how to rename tables. The same when you want to do a type. It's the same when you add a new whole database table, not just a column. Or if you deal with external system. The approach is always the same. Gradually migrate in this approach. So let's have a look what my pipeline, oh, now that works great. So what you see, this looks a little bit ugly in this big font, and now my pipeline started through. It did, you can see that. So basically it does git source, it checks out all these things. Maven is my Java build tool that builds up an application, and then of course I built a Docker image. So I build a Docker image using scaffold in this way, and then what I do, I push to staging environment. Curl, and then I hopefully have coffee instead of coffee, and then I can, oh god, and then I hopefully can gradually roll that out as well. So what I can do here now, works. And then in that way, I do a JX promote that basically promotes that version, what I had before, 6 to 7, to production. So I specifically name a version that is now going to the Git repository that we had. And then this is going to roll out that version, well, by doing a Helm apply. So again, similar to what that did on this on the staging cluster, it basically says, well, now we have a new version of this Helm chart, and what it does, well, it applies the new version of my Kubernetes resources. Basically applies a new Kubernetes deployment, right? This is how you would do a deploy on Kubernetes. But now what we do in the production environment is not only that, but it will roll out this events in a canary release. So this was from before, you can ignore that. That is now watching all of the events that happen for my canary, rollout mechanism. And then once that is the case, and this will be rolled out correctly, then we can check this out. So what this will do, it will create a pull request. Here, again, GitOps. That then waits for this pull request build. So that is already a quite sophisticated GitOps pipeline. Again, that now waits for the other builds to finish. So that does a Helm build that is currently rolling out and then running. What it does, it will apply this new Helm chart version to the production. And then once that is the case, the application then of that Helm chart will trigger our rollout. Okay, there we go. And now it is waiting for this build, which you can see here. So this check that's actually a GitHub feature that it says, okay, we basically wait for the merge of this pull request in our environment to do that check as well. So you not just go to your GitOps environment and say, oh, new version, just apply it, but you can add some extra checks, in this case, a pipeline run, for rolling out this environment and doing some validation whether it will hopefully work, or whether you did some mistake in your Helm chart in the syntax, for example, things like that. So now let's hope that this runs through soon. Let's reload again, and then we could see this. Hopefully, even though it didn't work at the beginning, but that would be cool to have. Oh, yep. Now that worked through, and then Jenkins merged that, and that means that now, it will be applied. And then it says, okay, great. Now, this is the old one. Yes. And then what we will see, that now this will gradually trigger the rollout. Let me do some curl. So that is now my production environment here. Basically, that still has the old version, right? And then once my new version is up and running here, that just happened now. That is basically the canary rollout. Then what will happen here? That it says, oh, new revision. Then it will gradually increase that version to 5% first, and it will be a little bit slow because of the network, unfortunately. And then at some point, but I can check it out here, we could have a look. While true is always a good idea, right? Coffee, coffee, coffee. At some point, once that is the case, we will once see a new version, and then we could apply that. And in the same way, if that is already there, then we would get some, let me refresh this, yes. Now we have the primary, now it only shows this version already, but that is now our production scope, and you see that this is still the same version on both sides, but this is then the monitoring part where we actually can have a look at it and on what the rollout is doing. Let me reload this. At some point, once it is there and it detected the canary version, yes, now we can do a comparison, and now you see left has 100% of the traffic, and then it will gradually increase that, and then slowly there you will get the new version. And it will says, well, now let's slowly increase it, wait 10%, and and so on and so forth, what you saw before. And now this is active. And this is now the automated version of what I would do by code of saying, okay, now increase it to 10%, 90%, right? Then see what is happening and then increase it further. And that is one example how we could roll out this using cloud-native technology. There's some key takeaways in order to limit the blast radius of your changes or potential errors. Well, we use such a progressive delivery approach, but the point is we want to do that in an automated way. to continuously improve. Migrate in steps and not in jumps is always important once you have a zero downtime approach, so that needs to be taken into consideration. And that is also one area where it makes a lot of sense to, well, work together with developers and ops engineers to have a DevOps engineering team to basically improve how you roll out your things and how you deliver value to your customers. The reason why I wanted to show you this technology is because I'm a huge fan of what the open source cloud native technologies are doing with Docker, Kubernetes, Istio, Flagger, Jenkins X. Why? Because you can always build these things yourself, and many companies are doing that and still doing that and have done that. But it enables so many more, especially smaller projects or startups and smaller companies to build up a very sophisticated technology or example in a limited amount of time by just getting started with these new technologies that already come with a lot of features being built in, which is open source and available for free, which is why I'm a big fan of that. So I hope this will was helpful. Спасибо большое, and thank you very much for your attention. Do you have some questions?
Коллеги, у нас не так много времени на вопросы. Давайте укладываться в регламент. Да, там показывают буквально один вопрос. Вот видим руку. Прошу.
Sebastian, thanks for the talk. But so if we're really talking strict zero downtime, there could be a couple of harder problems. In the case of just changing the deployment, suppose your deployment is something where session affinity is important.
Yeah.
You cannot just gradually disconnect some users with an active session. And in the case of the database, if it's actively being used, you added the temporary column, but immediately while you're still updating your application, the temporary column becomes inconsistent with the original one. How is this handled?
Yes, that's a very good point. To address the first thing, that is not only for cloud native technologies, but always the case. If you do a zero downtime, you have to see what is your state doing and where is it persisted, right? So in a database, that is fine if you take care of it, but then in sessions, you have to deal with that as well, right? So that means that your sessions then either need to be persisted on your database or handled otherwise, because if an instance goes down, then the user session goes down. So that just needs to be handled on an architectural level. So you need to take that into consideration. For the database, yes, that's correct, and that is the reason why. First of all, you have to wait for for each rollout of each individual database migration step, right? So that needs to be rolled out completely before you can do the next one. And once you do the step from changing the read to the read and write from from the old column to the new column, then you will need to copy all the data. That's correct. So this is what one of the script is doing, of saying, okay, now copy everything that has been changed in the meantime before you do the other change. Another thing to take into consideration with that, while you do the copying, you might want to have a paginated copying, right? So not say, oh, copy this the whole contents from this to that, because if you have a table with, I don't know, thousands or millions of entries, this copy can actually, stall your database and freeze everything for a few seconds. So then, you should gradually do that in a chunk of a few hundreds or something like that, before you do that rollout. But yes, that needs to be addressed. Otherwise, you would lose data that have been changed in between. So very good point, yes, for database migrations.
Thanks.
Коллеги, спасибо еще раз большое. Аплодисменты.